the first introductory lesson on torque. Now, torque is kind of like force, it's like an effort, but it's a turning effort, and it results in things rotating. So let's start right from the definition. So torque is equal to a force times distance. Okay, tor is Greek symbol tor for T for torque. Force times a distance. Now this will make more sense in a second. If I look at this object down here, okay, so there's an object, we fix it. You don't have to have a fixed things to apply torque all the time, but in this case it makes it just easier to discuss. A little pivotal point, a fulcrum, and there's an object which can rotate about that. Okay, how do we get that rotating? We apply a force. Okay, now we can apply a force anywhere around there. It could be a force at the end, could be a force all over, it could be underneath. Now that's going to be the force, and the distance at which it's being applied is what gives us the rest of that equation for torque. So the torque is equal to the applied force times the distance. Now a little bit more information about that. The distance and the force, the applied force, they must be at right angles to each other. So it's a perpendicular force over the distance, or if you like, the perpendicular distance over the force. So let's just do a real simple example, just so we know what we're doing. So we might have a force of 100 newtons, and we may have a distance of, I don't know, let's make it 20 centimeters. The turning effect on that is that torque equals force times distance. So back at the top up here, torque is equal to 100 times the distance, which is going to be 0.2. We want to work in SI units, so 0.2 of a meter is 20 centimeters, which obviously equals 20 Newton meters.